Hello guys, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all the competitive exams. So today I am going to teach you theory of computation and I will tell you how to start the preparation of theory of computation and what to cover and how to start all those things I am going to teach. So please confirm me once whether my audio, video, everything is clear. So I request everybody to please confirm once, is my audio, video, everything is clear. So myself, Murali Krishna Bokusamtram, I am having 21 plus years of teaching experience, and both in the GATE and also I worked in different engineering colleges. And this is about my brief profile. You can just have a look. Yes, this is about my brief profile. I hope I am audible and visible to every one of you. Is my audio, video, everything is clear? Okay. So I'm having 21 plus years of teaching experience, and these are some of my subjects where I'm expertise. Theory of computation, that's what I'm teaching you right now. Operating systems, computer organization, computer networks, digital logic, and information and communication technology. And I've mentored more than 50,000 students across the country, different core areas of computer science. And I'm also certified as International Engineering Educator through ISRO certification program, and also topper of NPTEL course in the theory of computation. So that's what I am teaching you right now. Okay. So please join quickly and mark your presence. Yes. Aarti, Seaman, good evening. Hope I am audible and visible to every one of you. Am I audible? Just confirm me once, everybody. Is my audio, video, everything is clear? Just confirm me once. Okay. Yes, Aarti, good evening. And please, others also. Before I begin the session, you can just share the class information with your friends. And also, you can do subscribe the channel. And please do like the session if you are really liking it. And please press the bell button for getting notifications related to these classes. And we are providing you different content, different free content in the YouTube. So for all those things to get, you have to first of all subscribe the channel once. And we are starting Gate Rankers Monsoon series. It is a free course. It's a free course in the YouTube. It's the most important topics of electrical, electronics, and computer science. It is a live from 10th July. Okay, so please do subscribe right now, and you can get all the benefits. Okay. Now let's move on to the next. And actually, this is not only for computer science; it is for electrical, electronics, and computer science. All the three branches. It will be starting from 10th July with all the expert faculties. Yes, Sandeep. Hello, Sandeep. How are you? Am I audible? Yes. Now there is just a moment. There is a workshop. It's a live interactive workshop on coming Sunday at 12 noon. This is about our 7 months enough to get All India rank under 100 in the gate. So this is taken by Dheera Sadhana sir and Abhinav Neki sir. You can just make use of this and try to attend this workshop without missing. Okay. So shall I go ahead? I hope, yeah, you people are able to hear my voice clearly. And let me start the session. Actually, I wanted to brief you what is that I am going to take right now. So in theory of computation, within this half an hour lecture, I wanted to give you how to start the preparation of TOC. So first of all, you see the GATE syllabus. This is GATE syllabus and all other competitive exams. Okay, in the ISRO, in BARC, and Tata Institute of Fundamental Research. So everywhere this theory of computation is very important, and this is the syllabus as per the recent GATE pattern. And almost if you prepare for GATE, and it is useful for all other competitive exams, including the UGC NET for theory of computation. Okay, now. And regular expressions and finite automata, context-free grammars and pushdown automata, regular and context-free languages, pumping lemma, Turing machines, recursive and recursively enumerable languages, and undecidable. So this is the just syllabus, and what is to be covered in each topic, okay, and how to start the preparation. So what are the best books to be followed? All those things I will give you in brief, okay. And meanwhile, if you have any doubt related to this subject regarding your preparation strategy and making the short note, okay, and how to remember the concepts, all those things, if you have a doubt, you can just ask me in the chat box. Not only in the chat box, even after the class is finished, You can share your doubts in the comment box also. Okay, and please do share this class information with your friends also, whoever are not present here, and you can subscribe the channel. Okay, shall I go ahead? Yes, confirm me once. Shall I go ahead? Yes. Thank you very much, Aarti and Sandeep, for joining. And now let's and others also. Yeah, yeah. Okay. Now let's see the basics of theory of computation. First, you have to learn what is alphabet and what is a grammar. So basically, the subject is about theory of computation. Subject is about formal languages and automata theory. So you have to learn about what is a formal language. Okay, and usually formal language is nothing but a language with the formal alphabet. For example, English is a formal language with alphabet A to Z. Similarly, all computer languages are also formal languages originated from some type of languages like type 0, type 1, type 2, type 3. So Chomsky have defined a hierarchy of formal languages. You should have a basic idea about all those formal languages. Okay, so the subject actually in this session you can have an abstract view of the entire subject, what is to be covered and how you should cover and how to start all those things. So to begin with, so you have to start with alphabets and the grammar. Okay. So different notations followed in the strings, characters, everything. All operations we follow in the languages, everything. And automata theory is nothing but it abstract model of the formal languages what we study. Okay. Grammar is the just it is a grammatical representation, set of rules to frame the sentences. Okay. You learn basics of formal languages like alphabets, grammars, and strings. Okay, and operations on strings, languages, operations on languages, and all the analysis of different types of languages from different textbooks. Okay, because different textbooks will follow different notations. Okay, when you see a question in the gate exam like with a new notation, you should not be embarrassed because if you are already accustomed with that style of notations and all, it is great. That's why you can refer to different textbooks. Anyway, if you attend all the classes, paid classes and YouTube classes, you will understand the notations very easily. Okay. Now coming to so machine characterization, actually automata is nothing but it's a machine characterization. It's a language recognizer. Okay, for making a computer to understand the language. Okay, for a language we require to have some abstract notation. So that is called machine counterpart or some mathematical representation of a language. Okay, so just you see this subject in an abstract view so that when you go to the content in detail one by one, it is easy to understand. Okay, now I hope I am audible and visible to every one of you, and you are able to follow me. And basically, formal language is an abstract of general characteristics of programming languages. And a formal language consists of set of symbols and some rules for formation of sentences. And just like of we follow some grammar rules in English language, Hindi, Telugu, whatever it is. And formal language is set of all sentences permitted by the rules of the formation. Like every formal language will have its condition. Okay, so those condition to satisfy for taking a string. Okay, and a pattern of the string also will be given. And you have to study about alphabets and strings. To begin with, actually the basic background for this is discrete mathematical structure to know the sets and relations. But without discrete mathematics also, mathematical foundation of computer science in some universities, you can directly start the theory of computation if I teach from the basics, like what is alphabet, what is a language, what is a string, what operations you can perform on the string, and typical operations, and comparison of languages, all those things, and properties, everything. Okay, so basically alphabets and strings like a finite non-empty set of sigma is a symbols called as alphabet. Example, let us suppose sigma is equal to 0, 1. So this is containing alphabet symbols 0, 1. You can take any alphabet value, small letters from 0 to 9, A to Z we can take, and special characters we can take as alphabet. Okay, and digits we can take, binary numbers we can take, all those things. And string is nothing but some collection of characters defined in the alphabet. For example, 0, 1 is an alphabet, then 0, 1, 0, 1 is a string or alphabet 0, 1. 0, 0, 0, 1, 1, 1, 0 is also string defined over the alphabet. And also grammar. Grammar is nothing but some mechanism is required for representing the language. So by means of some grammatical notation. That is what A grammar is a mechanism to describe the study languages mathematically. Like, for example, if you see the entities of a grammar, you will have the set of variables, terminals, productions, and starting symbol. Variables are called some all capital letters we use. Terminals, all the alphabets of the language, and production is a set of rules how to generate the sentences. And starting symbol is also variable, which is a special symbol called the start variable. Hope you are following. Is it clear? Okay. And if you have a doubt, please ask in the chat box. And please do share with your friends, and don't forget to subscribe the channel if you have not yet done it. And this summer crash of theory of computation will be continued till July 8th, except on Sundays. Remaining all days will be there. And try to attend all the classes, please. Okay. I hope everybody will attend all the classes. Then, in detail, on every day, one topic I will take, and how much depth of the topic you have to cover, and everything I will tell. Okay. This is very crucial and important. Even the people who have already attended theory of computation also, better you go through this once. Okay, now. And this is just the coverage what you have to do. And today's session, how to start the preparation and what is to be studied and all, I will just explain. So just you can see now formal languages is containing 4 categories. Regular languages, grammatical representation is regular grammar, and machine counterpart is finite automata. So this entire regular languages are there in the syllabus. Okay, in your syllabus, complete regular languages you have to study. Okay, and first you better start with the regular languages after covering the basics. After covering the basics of languages, alphabets, strings, operations, and everything, after understanding the notations of different languages, after analyzing so many languages, hundreds of languages, what is right string, what is wrong string for a language, then you have to understand the type of languages, what is regular and what content you should cover in the regular languages. And context-free languages, context-free grammars, and push-down automata. Context-sensitive languages, context-sensitive grammar, and linear bounded automata. The first one is a language name, second one is a grammatical representation, third one is an abstract machine. That is what machine model, machine counterpart. And then recursive enumerable languages, unrestricted grammar, and then Turing machine. So this is what the content is. These are the 4 types of languages. But in our syllabus, the coverage should be regular languages complete content, context-free languages complete content, and recursive enumerable languages. Actually, this particular part, context sensitive, is not there in our syllabus. Okay, already I have shown you the syllabus. Okay, I hope you are able to hear my voice. Is it clear? Shall I start? Shall I go to the next slide? Yes, yes or no? And yes. Now coming to, yeah, fine, thank you. Now coming to Chomsky hierarchy of formal languages. So actually Noam Chomsky defined there are 4 types of formal languages, where all the computer languages have been originated from them. Okay, those are you can see. Finite state machine is an abstract model for regular sets. You should cover that. First, you should cover that. And DCFL, deterministic context-free languages. Those are accepted by push-down automata in a deterministic approach. And again, context-free languages. And then decidable languages, means recursive sets, both CSL, okay, and also undecidable languages, partially decidable, recursive enumerable sets. Turing acceptable, Turing recognizable. These are the different ways. Okay, just once again I will show you. So first of all, regular languages. Regular languages accepted by finite state machine, and DCFLs accepted by deterministic push-down automata. CFLs accepted by non-deterministic push-down automata, and then followed by so I am not shown the context sensitive languages as they are not in the syllabus. And decidable languages are recursive languages. Those are also called as Turing acceptable or recursive sets. And partially decidable, also taken as undecidable languages, Turing recognizable languages they are. And recursively enumerable, we can say. And the languages which are not recursively enumerable, those are called non-computable languages, non-recursive enumerable. That means the complement of recursive enumerable sets. So this is the general hierarchy. So the type 3, type 2, type 1, and type 0 is the hierarchy from low to high. Type 3 is regular, type 2 is context free, type 1 is a context sensitive, and type 0 is a recursive and recursive enumerable. And relation between the formal languages is like this. So regular languages recognized by regular grammars, those are called type 3. Context free languages recognized by push down automata, and grammatical representation is context free grammar, and that is a type 2. And context sensitive languages recognized by linear bounded automata, and the representation of grammar is context sensitive grammar, it is a type 1 grammar. And in addition to that, we have recursive enumerable languages, that is a type 0 languages. Okay, so every type 3 is a type 2, every type 2 is a type 1, every type 1 is type 0. That means every regular grammar is also context free grammar. That means every regular language is a context free language, but all context free languages need not necessarily be regular. That means there can be some CFLs which are not regular also. So if you can visualize this, so you can understand the subject fantastic, because this visualization is required before you begin the preparation. What is there in the subject? What is the content you have to cover? So this is a total hierarchy. So if I directly start just regular languages, you do not know what is a language. If I say regular language, why it is named as regular? If I say context free language, why it is named as context free? All those things you will get a confusion. That's why you have to visualize the subject in an abstract view, abstract way, okay, so that when you go in detail, it is very easy for you. And every type A language is including type I plus 1. That means type 0 including type 1, type 1 include type 2, type 2 includes type 3, like this. Okay, and that is the criteria here. And if you have a still doubt, and don't hesitate to ask in the chat box. Okay, now if you have any doubts, you can ask now. And shall I go ahead with the next slide? So this is the hierarchy. So this entire hierarchy, except this context sensitive languages, you have to study all those. And the beginning should be, you should begin with the regular languages. You should not begin with Turing machines. Okay. Now coming to a relation between the formal language and formal grammars, you can see it is like this. Regular languages type 3 recognized by finite automata, and context free languages, it's a type 2 recognized by push down automata. That means push down automata is powerful than finite automata. So it is a comparison of the powers of the machines. Okay, and context sensitive languages recognized by linear bounded automata. LBA is powerful than PDA and finite automata also. And Turing machine is more powerful. All recursive enumerable languages recognized by Turing machine. Okay, this is how the relation is defined here. Okay, so that means every regular language is also context free. So we can say type 3 is the subset of type 2, is the subset of type 1, is a subset of type 0. The subset and superset nature is defined based on the grammar rules. This relation of the formal languages is defined based on the grammar rules we follow in the languages. What do you mean by grammar rules? So some formation of sentences, we have to follow some restrictions. So those are called the grammar rules. Language to language, grammar rules will vary. Production rules will vary. Okay, so every generally, if you see the relation in detail, relation between the formal languages, it is like every type A language is properly including all type A plus 1 languages. Every type A language is properly including all type A plus 1 languages for I values 0, 1, 2. This relation you should understand. That means if you take I value 0, type 0 includes all type I plus 1, type 1, type 2 and type 3. If you take I value 1, so type 1 includes type 2 and type 3. If you take I value 2, and type 2 includes type 3. So these are the things. Every type A language is properly including all type A plus 1 languages for I value 0, 1, 2. Okay. So that is what the relation between formal languages and formal grammar. And still, actually, I wanted to make this as more like interactive. And if you have any doubts regarding the starting of preparation for TOC, and please ask me, don't hesitate. So please try to make use of this session for asking your doubts. Okay, from tomorrow onwards, again, I will continue taking one topic, and I will tell you how to prepare the topic, how depth you have to prepare, and what is to be covered. So the total content I will just give you an outline. Okay, can you just ask me any doubt now? Yeah. And if you are not yet subscribed the channel, please do subscribe it, and also please share with your friends. Okay, and don't forget to press the bell button for getting notification. Actually, we are giving you a different series in the coming monsoon also. So some most important topics also will be covered from July 10th. We'll be starting it, and each faculty will take of their subjects with most important topics. Okay. Yes. Anybody is having any doubt, please ask me. And don't forget to subscribe the channel, and don't forget to share with your friends. Yes. And if you have a doubt, then I will continue. Otherwise, I'll stop the session. And before that, I just once again wanted to tell you every day at 10:15, I'll be taking theory of computation. Okay. Today, just it is only a beginning. I just shown you the total content of TOC and the preparation sequence I told you. Like you should start from the scratch. So if you are not aware of anything about the subject, also you can understand if you start from the formal language, strings, alphabets, and all. Because anyway, some basic mathematical knowledge will be there for every engineering student. Okay, so that knowledge is sufficient. And if you are already gone through the discrete mathematical structure or mathematical foundation of computer science, it is much helpful in understanding some of the typical problems or typical notations. Okay. Thank you so much, and see you all tomorrow at 10:15. Okay, so please don't forget to share this with your friends and subscribe the channel. Thanks a lot. See you all. Good night. Bye bye.